Intelligent Transportation Systems Podcast. Hello everyone, welcome back to the ITS Podcast. This is episode 22 for February 2015. I'm Javier Sanchez Medina from the Intelligent Transportation Systems Society. Here we are again with the best periodical podcast on intelligent transportation science and engineering. We have a very interesting menu for you today. Last November, the ITS Society started a distinguished lecture series with an event organized by our Japanese chapters, the Nagoya Chapter and the Tokyo Chapter. They organized a super attractive event aiming in particular to our featured colleagues in the University of Tokyo. They could attend to a lecture by Mr. Tsuguo Nobe from Intel and Professor Shinpei Kato from Nagoya University on autonomous driving. For this special occasion, we have interviewed both of them, so all our selected community can learn better how was it. Of course, we also have a news mini-section by Dr. Maryam Kaveshgar. She will tell us about the recent striking event also related to autonomous driving. Do you know why some countries have their vehicles driving on the left and others on the right? You will know if you hear a news mini-section by our volunteer Maryam Kaveshgar. And that's it. Get comfortable in your chair because we are starting now. Enjoy.
This is the news mini-section for episode 22nd, February 2015 by Maryam Kaveshgar. CES 2015 had a large auto presence. Autonomous and semi-autonomous cars were everywhere. One of the hits was BMW's 360-degree collision avoidance and parking assist. The BMW i3 could park itself 100 times a day without incident in an unlit garage in tiny spaces. Both Audi and BMW have already demonstrated that they can self-drive as fast as their cars can go. The Audi A7 concept is able to drive itself between the speeds of 0 and 70 miles per hour, including making lane changes and passing maneuvers. Ford didn't have a new car to show. It still proclaimed it would strive to be the first to offer an autonomous vehicle to the masses. Mercedes says it will make the dream of its futuristic F-015 a reality by the year 2030. There are three challenges preventing Mercedes and its contemporaries from bringing self-driving cars to market. The first is the question of the degree of autonomy. The driver can literally turn his back on the road, but that's a long way from becoming viable. The second challenge is the complexity of the traffic situation. The third challenge is environmental. These sensors work perfectly well in good weather and daylight, but they have limitations. CES 2016 will definitely be a bigger deal, full of wonderful auto tech. Finally, we have good news regarding the recent Intelligent Transportation Systems Society Board of Governors elections. 5 brilliant members of our community have won their place in the BOG.
Transportation in History by Maryam Kaveshgar, PhD candidate at Simon Fraser University, Canada. Have you ever wondered why some countries drive on the left while the others drive on the right? Today, about 65% of the world's population live in countries with right-hand traffic and 35% in countries with left-hand traffic. The origin of this varies based on the time period and country, but primarily throughout history, people use the keep left rule. It has only been very recently that the world has predominantly switched to the keep right rule. Recently, archaeologists found a well-preserved track which shows that ancient Romans drove their carts on the left. In the Middle Ages, horseback travelers rode on the left side of the road. As more people are right-handed, a horseman would thus be able to hold the reins with his left hand and keep his right hand free to offer in friendship to passing riders or to defend himself with a sword if necessary. This custom was given official sanction in the year 1300 when Pope Boniface declared that pilgrims headed to Rome should keep left. This system prevailed the Western world until the end of the 18th century. At that time, this tradition started to change in France. We are not sure why the French switched to a keep right system. Some people believe it is because the French revolutionists did not want to obey anything that had been ordered by the Pope. Others say it was because they didn't want to use the same rule of the road the English used. Still others say it was entirely Napoleon's personal preference. Whatever the reason was, Napoleon enforced the keep right rule to all countries he conquered, including Germany. Fast forward to the 20th century, as Germany conquered countries in Europe, they forced their keep right system onto those countries. England was never conquered by Napoleon or later Germany. Therefore, they kept the traditional keep left rule of the road that had been used there for hundreds of years before. As the British Empire expanded, this keep left rule as a law spread throughout the world. However, this has not endured in many of these former British-ruled countries, except for a few, including India. So if you see anyone wondering why people in Britain and some of their former colonies drive on the left, you can remind them that a few hundred years ago, everybody used this system.
Hello again. Here we go with our ITS Society's Distinguished Lecture Series interviews. We sincerely believe you will enjoy them. Very well, we are now with Mr. Tsuguo Nobe. Nobe-san is currently Chief Advanced Service Architect and Director at Intel Corporation. He has a very interesting profile for our community, since he has been Chief Service Architect and Program Director at Nissan, and before that, CEO of a very large online game company called NC Japan. Hello, Nobe-san. Can you please provide more detail on your background to our listeners?
Okay, thank you very much, Jabi. And yes, so as you introduced myself, I was working for an online game company before joining Intel. And even before, between those two companies, I was working for a Japanese large automotive company called Nissan. And also, before the online game company, I was working for a PC business in an IT company called NEC in Japan. So that's kind of a overall kind of a career development within myself.
Nobe-san, you were the first presenter of the recent first Intelligent Transportation System Society's Distinguished Lecture, celebrated last November 27 at the University of Tokyo. I've seen you delivered a very interesting talk setting a parallelism between connected vehicles and online gaming. That's extremely refreshing. Can you please roughly explain to our audience what is that new concept?
Yes, I think it's not a kind of a new concept because it's a historical evidence and also it was held in the past. But it is important because with the start of the internet access by using ADSL or fiber to the home type of the broadband technologies, the people can make access to the server, and in the server, some game type of the functionalities would be calculated, and many people will be flocked together on the server, and then they can play the game. And basically, it was possible because of the ADSL and also the always connected type of the broadband internet access. And there are around 5,000 people clicking around, making a kind of access to the server. And at the same time, those people enjoy the game. There's kind of a virtual map on the server, and the people may send out the positioning, location of their, basically the position inside the game. And then the game server can calculate what kind of activities would be held by the people behind the PC. So there are kind of course, SNS type of functionalities embedded inside the game. And this kind of access to the server by the people could be switched over or changed into the kind of if we place the people to the car or vehicle, maybe that cars would be hooked around to the server, and then we can provide many functionalities. For example, instead of people, we can pick up the location of the vehicle, then we can calculate the status of the traffic jam or such kind of thing. So such kind of combination of the client server could be easily implemented to the kind of a relation between the vehicle and server. And it was held just on the game between the PC with person. Then those people may make access to the server. So it's just the same architecture between vehicle and game.
Mm-hmm. Nobe-san, do you think that modern mobility has to evolve through the so-called gamification? I mean, do you think we must engage drivers to new transportation technologies, making them not just safe and efficient, but also enjoyable?
I think that, technology itself is very important. And for example, that it's not just a kind of game, but so it's not so enjoyable. But we can provide a very safe control of the vehicle. Well, of course, we can provide very important information to our drivers. For example, we can, of course, tell that this road is slippery, for example, or there are some kind of a very huge rainfalls is there in a very spot area of the road, so that we can provide such kind of a good information to avoid such kind of a dangerous type of environmental situation, so that we can drive away from those situations. Then we can provide a very good information to drive safely. So it's not so enjoyable, or enjoyment is not the kind of a target, but we can provide a very advanced safety services using the connectivity to the servers.
Mm-hmm. Well, that's interesting. Thank you very much, Nobe-san. We have a classic question at the ITS podcast to people on autonomous driving. Do you believe we will have sometime in future fully automotive vehicles when we prove they can be safer and more efficient than us humans? I think that with your wide-angular professional view, you may provide truly useful insights on this.
Okay, of course, I was working for the Japanese vehicle company for 8 years, and I was especially working for implementation of the ICT, information communication technologies, to the vehicle. And from my experience, there's some kind of a conceptual gap between the vehicle developers and the ICT or IT developers. And also the very kind of actual difference of the technological advancement, basically speed of the advancement is very different. For example, the IT may advance every year twice. I mean, with the kind of a Moore's rule, which was mentioned by the Intel Dr. Moore. He said that every 2 years, the performance of the computational power would be doubled. But I think that such kind of advancement is accelerated, and recently that maybe the advancement of the IT technology would be like twice or doubled by year. Each year, the performance will be doubled. So that when compared with the vehicle technologies, the IT advanced a lot. So that from the insight from the IT kind of a background person as myself, I can tell for the future that the IT may help a lot to provide the very safe or advanced services. And maybe, of course, IT technology may take place of the human's eyesight or even the brain itself. So that IT may assist people to drive safely. If there's a kind of a blind spot, we can tell that there's a kind of object or hidden something there. So we can assist them, and sometimes we can take place of the actual driving by IT. So that when we take a look at the advancement of the IT and also the communications, I think that those devices, ICT basically, may perform better than human beings. Then, as many people said, that some kind of traffic accidents or fatal accidents especially, will be reduced very quickly. So in the future. So such kind of a system of the IT may provide a very good opportunity to provide basically fully automated vehicle in the future.
Mm-hmm. Well, that was it. Thank you very much for your contribution to this first ITSS distinguished lecture and for your mind-shaking new concept you have kindly shared with us today. Domo arigatou gozaimasu.
Oh, thank you very much.
Sayonara.
Sayonara, goodbye. See you.
Hi there! We are running a new contest to celebrate the second anniversary of the ITS podcast next May 2015. The follower that can get the largest amount of new followers to subscribe the ITS podcast email list will win an iPad to better enjoy our contents. How to contest? Well, you have to provide us with a list of the email addresses of the new followers attracted and the approximate date of their subscription. To be eligible, you have to attract at least 30 new subscribers. So, first step, go and find as many potential ITS podcast followers as you can. Second step, send them the email list subscription link you can find at itspodcast.com, inviting them to subscribe. Very important note, when they use that link to intro their email addresses, they will have to confirm their intention to join our distribution list through a confirmation email they will receive in their inboxes. Unverified emails will not be counted as valid. Third and final step. When you know they have subscribed, send the email addresses and subscription date list to itspodcast@gmail.com. itspodcast@gmail.com. So please go and help us. You can win an iPad. Now let's get back to our today's interview. Hello, we are now with Professor Shinpei Kato from Nagoya University. Professor Kato is a young, brilliant researcher, co-director of Parallel and Distributed Systems Laboratory and Embedded and Real-Time Systems Laboratory in that university. Professor Kato delivered the second part of the first distinguished lecture celebrated at the University of Tokyo last November 27. He shared a very attractive video on the different approaches to autonomous driving in 3 different leading car makers right now. Hello, Professor Kato. Can you please introduce yourself to our listeners?
Sure, thank you. So, hello. My name is Shinpei Kato. Well, my research expertise is computer science. And I'm pretty interested in autonomous driving because nowadays, this technology needs more computing power to ensure safety and to make more entertained. So I believe computer science is more becoming kind of one of key domains for future autonomous vehicles.
Mm-hmm. Good. Professor, can you please describe your presentation?
Sure. So the first half of my presentation was about the current state of autonomous driving from the viewpoint of both car makers and IT companies. Specifically, car makers such as Daimler and BMW, they are more safety oriented and they really consider production of autonomous driving technology. While Google is more technology oriented and they seem trying to introduce new technologies such as artificial intelligence into the car market. So that was the first half of my presentation. Then I presented some academic research on autonomous driving, especially including recent work done by Nagoya University. And to summarize, we have an open source software platform that could underlie the future research on autonomous driving. That was the second part of my presentation.
Mm-hmm. That's interesting. Well, Professor, your communication seemed to be very carefully aimed at engaging young students into our field, intelligent transportation systems. Is that so?
Yes, that's right.
Do you think you succeeded? Did you perceive interest?
We'll see it in a few years, I think, because this project has just begun. But I can say that autonomous driving needs multidisciplinary collaboration, not only just vehicle technology, but also computing, data management, security, privacy, and most significantly, artificial intelligence. So we want more students, more researchers from very different areas of research to make an innovation in autonomous driving.
Well, Professor, congratulations and thank you for your participation in this publication and of course in the development of this first distinguished lecture. Arigatou gozaimasu, Professor.
You're welcome. Thank you.
Sayonara.
Bye.
Okay, this is the end of today's episode, but we are already working on the next. So if you feel like it was too short, please check out our previous episodes at ITSP.cicei.com. We have 21 other episodes ready for your ears. And you could even help us a lot posting your comments or disseminating them. This podcast is sponsored by the IEEE Intelligent Transportation Systems Society, website design and managed by the Innovation Center for the Information Society at the University of Las Palmas de Gran Canaria in Spain. Soundtrack developed by Rubicon, language advisory by Manuel Arbelo and Professor Song Williams from Clemson University, South Carolina. We'll be back soon bringing you again the cutting edge of science at the Intelligent Transportation Systems podcast. Thanks for listening and drive safe.